Okay, let's go ahead and get started. I'll share my screen if you're attending from home. We left off last time talking about generics. This is an example. We're defining and using a generic class, generic class, and then less than, t greater than. Um, and everything down here is very generic. And we create an example list, but that t can be any type. For example, down here, generic class, we have it as a string. Again, it doesn't have to be a string; can be any double or whatever you want to put in there. So it's just this is just generically defined, so you can put any data type in there. Okay, constraints on generic type parameters. Constraints on generic type parameters are useful to restrict the kinds of data that can be used for type arguments to instantiate a generic class. Compile time error will generate if a client code tries to instantiate a generic class by using a type that is restricted for a type parameter. Now we got our where keyword. So this is where we're talking about our constraint. The where keyword is how we apply those constraints. And so we got the same type of idea here, class and class name, and then your less than, your type, and then greater than. And we're t, and then we specify the constraint. These are the constraints we have. T colon struct, T colon class, T colon new, U, and interface name. Struct says that T must be a value type. Class says must be a reference type. New says must have a definition of public default constructor. Must have a definition. U must be of child must be or child of type U. And then interface name must be or implement a specified interface. Like this example here, pretty much the same code that we used above. The only thing we put on different, from what I can see, is where T colon struct. And let me close that. And then down here, we're using the int for that. Here's another example where we use class. Again, what's different is this where right here. And down here, we're using string. And for the where T is new, you see it has a public default constructor. Again, the constructor always has the same name. Notice my class. Then we got T new here. And our generic class, it looks like they've left quite a bit out here, but they're just demonstrating it. It says here T is my class. So you see it says generic class, my class. So right here, that T is saying it's coming from a constructor, which we indicate as my class. If I go back here, class my class. So as defined here. And T is base class. Remember we had a class as a person, and then we had students a person, and then you can break it down further. But anyway, you got your generic class here where T is a person. Now that's not a reserved word. That's referring to this right here, which also is referencing that. So then down here, you see the generic class person, genper, and student is also a person. This is also valid. See how we do a student? Because remember, this inherits from a person. A student is a person. Or you could have a person directly. So you don't have to have both of these. They're just indicating two separate examples. And the last one, our T interface name. Actually, I guess there's one more. Now, this one, I'm not seeing where I person is defined. I'm pretty sure if I take that over, assuming I could actually highlight it. Okay, so if I were to come over here and put in class person, I person, and then we got class student, who's a person. Then down here we have class, generic class, T, where T is an I person. And I won't do every one of them. I'll just copy this one example over. Because there's nothing to run. See here it says T is an I person. So we're referencing it directly. Or you can put person in there. And person is an I person. And here T is a student and inherits person, which implements I person. So all three of those we go back to I person. Remember I said I wasn't seeing any code for that? Oh, there isn't any. So that's just an interface we can't see in this code example. And we got word T colon U, class person, student's person. And then we got T comma U, where T colon U is a, we're going to see that. So we got a student is a person. And we got generic class, person, comma, person. We also got student person, and that's referring to this bottom part here, T comma U. And it shows this relationship. So person is a person. That's kind of weird. It kind of points to itself. And then this one's a student's a person. So inherits. So these are all ways you can do some inheritance. Well, not all, but these are some ways right here that you can see the do some inheritance. We can apply more than one constraint on type arguments. So T colon base class and new, that says that it has to come from a base class, and we have to have a constructor. So we got class person and then string name, but specifically right here we got our person. That's our constructor. Again, your constructor always has the same name as the class, and it's never you see it doesn't have a void, doesn't have any of that. It's not actually returning. It's a constructor, creates an instance. Then down here we got students person. And then our class here, generic class, where T colon person then new. It says where T can only be person, which is a default constructor. So the fact that this is a person by this class name, not that it's actual person, and it's got a constructor, that's when you can do that. And says a student is also a person. So student inherits from person, so you can use it also. Even though it doesn't have a constructor directly. The constructor for it comes from person. I think probably the best thing to get out of all those is understanding what that notation implies. Not that you're going to implement that on a regular basis, but that you generally understand what it is it's doing. For example, if I come over here and I do a file, new project, with Visual C# and Windows Form app, and click OK, and I'll go ahead and save that. Okay, and view, I guess, and looking for my toolbox. Oh, there it is. Okay. Drop a button on here. List box. Text. Text box. Double click the button. What you're going to be seeing is items like this. And we'll be talking about a lot more of these other items too. What does it mean exactly? We'll be going back to the windows in case you're curious here shortly. But we will need to cover objects so that when you're looking at this, you understand what in the world this is doing. Maybe you don't understand everything about it, but you understand the inheritance involved with it. when you see this right here, system.windows.forms.button. There's a lot of inheritance that's going down through here, and it's implied with a dot framework. But that's why when you go to look at a button and you don't see everything being defined, because a lot of it's being inherited down. You go to Form 1. Notice my name on my class, Form 1. Notice the name of this right here, Form 1. You should understand what this does right here. You should understand this is a constructor. See how they're the same names? There's no void, there's nothing returned here. This is creating an instance. So it's creating an instance of my form. So if you're wondering, well, where's the code that's creating my form? Well, it's right here. I don't know if I can right click on this and go to it or not. Let's go with the definition. You see this is where they do the initialize component. Oh, good. It shows all the code. This is referring to that particular instance. Dot button 1 equals new system. The new, you should know that creates an instance of something. In this case, it creates an instance of a button. Typically, you don't want to come in here and change it directly. But if I were to change it in all the correct places, and I won't, I'll break it. Go ahead and tell you that now. But if I want a new button, button 2, then it'll be a new system.windows.forms.button. And show potential fixes. You see right here, I put my button or my namespace Windows Form App 8. Windows Form App 8. I didn't see button up here. Must be in a different file. Generate property. It looks like the right place because I see right above it, it says private system.windows. Probably looking right at it in terms of what file that's in. But if I click the generate field there, then that's defined. This is where you're telling the word appear on the screen. Again, understanding what's a method, what's a property, helps you with all of this. Not that, again, that I'm going to get this right. If you don't have it in all the right places, it won't show. And you see they got a lot of different items here. Got this dot button 2 dot location equals new system dot drawing dot system dot drawing. Again, when you look at this, this helps you understand what it's where it's coming from, what it's inheriting. Drawing dot point. See, I would assume this was a position. Point. Oh, it's just specifying a point, like a point on your screen. Like this is going to be at 100, 120. So location, that has to be a point, I guess. You see it says system.drawing.point. This dot button 1 or 2 dot name equals button 2 given a name. Size, this dot button 2 dot size. In case you're wondering where I'm looking, I'm just looking up above. I'm following the lines that they have there. And looks like this is a new system.drawing dot size. Assuming that's width and height. So 170 and 200. Tab index I probably don't need. They'll probably give me an error if I don't put it. But text I probably don't need. This is an event handler. It's a kind of a something where you associate a button click with something being done. Now realize that this size here, this is a definition that's been done, and we'll come back to that. I'm just looking to see if there's anything else I need. Oh, here is where the private was. So I want to change that. I want to make sure that says system.windows.forms.button, button 2. I was wondering, it looked like it was in this code, but I was looking for it up above. Now let's start to see if I got it everywhere. If I've successfully put all the necessary items in there for button 2, we should see a button 2 appear on our screen. If I haven't, then it'll give us an error. Or not even show. See, I don't see a button 2 at all. So that means I did not put it in all the right places. Something's missing. Perhaps these items that I skipped. Up here. What did I skip? I skipped tab index. I skipped all those. So let's copy those. I'm guessing for sure that I don't want the last one. I'll make that 5. Let's make this button 2. Back color is fine. If I define this, well, I haven't defined the other one. Let's try that. And all these should be 2. This is a perfect example why you don't want to create your forms this way. And I don't have a definition for that, so let's try running it. Just double check that I didn't put it underneath another button. Location, location. Yeah, I don't see it. So it must be other places where you set it. Now, realize this is all object-oriented inheritance we're looking at here. This is creating a new instance of a size, whatever size is. Now, if I right-click on size, you see I can go to definition. And struct we talked about. But even more than that, notice how this is overloaded. We got size, size. And one of them is passing in the width and the height, both of them integers. And one of them is passing in something called a point. And again, initializes a new instance of the system.drawing.size structure. Because again, that's a constructor. Notice how it says size here, size here. Now I'm not object genius. I can't say I understand everything in here, but you don't have to. That's one thing you'll learn in computer science. It isn't necessary for you to understand 100% of the items you're looking at. But you should generally, when you're looking at this, understand what these different components are. Um, well, there's the other definition. So then there's our point. If you're trying to figure out items that you can use, you can come here and you can look at the definition, and that gives you an idea of what you can use. Looks like for the size, I can use the plus, minus. These are overloaded, aren't they? Remember how we talked about that? I think we even looked at an example of overloading those. Remember, these come in pairs. If you have equals equals, you have to have a exclamation equals and not equals. Anything that's private you can't use, but all these public ones are ones you can. Anyway, probably more than you want to know about that. um, I'm curious what I did wrong on the button for it not to appear. I expected something to be there, or at least an error. Excuse me. Oh, this dot controls dot add this button to. Yeah, if you don't actually drop it on the form, it doesn't do any good. Okay, I think that's it. There we got our second button. Doesn't do anything. First one doesn't either. Um, Now, you don't want to come in here and manually code those, in case you're wondering. Not that it'd be that hard, but when you got a nice IDE that does that for you, then there's no use for you to come in here and change these. Now, notice that and they work together. You notice my button. My button is at location 400 and 120. If I come back to my form 1, you see we now got our button 2 on here. If I drag it down here, now I go back to my designer, you see the new location is 922, 432. I suppose there would be one time where, and I'm not sure how you'd even implement it, but if you wanted to dynamically uh, draw buttons on here, not drop them on there, but dynamically do it, then you probably come over here and you could do it. Maybe. How vague is that? Private system dot Windows. I know I won't be successful with this. Forms button array. Um, and then like that. I never have done this in case curious. To declare a fixed size buffer field, use a fixed. Where did I get final at? It says fixed. How about if I put 5 in there? Nah, I don't know how to do it. Unless I'm putting it in the wrong part, which I'm famous for. I was putting in the wrong part again. I don't know how many times I'll do that wrong. Then up here, if I put a 5 there. Cannot be specified with new. So button array. Button array. Button array is equal to new. This dot. What if I can just say button? Five. And then for int x equals 0, continue while x is less than 5, x plus plus. Copy those. Paste them in here. And the point location, I want to do, let's say, 2. 100 times x, comma, and 50 times x. That should dynamically, based upon this, change the location or where that's going to be. Given it a name, 2 is nice, but not every one of them should be 2. So let me do a plus here, and then I want to do x plus 5 to string. What this will do is first time through x is 0, 0 plus 5 is 5, and it'll convert that string and concatenate it on the button, in theory. Size I'll leave alone, tab index, let's say 5 plus x, just to make sure they're all different. Text here shouldn't matter, that shouldn't matter. There's a specific reason I'm doing this, and I'll talk about it here in a minute. Because you might be looking at this and assuming I can get it to work. That's always iffy. Okay, this dot controls dot add this dot button array x. That would assume I have 0 to 4, which I think is what I created up here. Not even close. This should be button array dot x. Had the wrong thing hard coded. Control V. Control V. Control V, Control V, and Control V. Let's see if I'm even close. It doesn't like something there. What's it say? Local variable intx. Point can take two integers. That'd be right. 100 times x, 50 times x. I'm referring to an instance. I did a new. Object reference not set to an instance of an object. This dot button array x equals new button. Then what I need to new up here. Yeah, I guess I would. I shouldn't have to declare that down there. There it goes. That is strange. I didn't expect new there. See, I got all these buttons now. Now I could use some of the other resources to not hard code like 5 in there. This is the concept. It isn't important you understand everything I did. Get the meeting going again here. There we go. Okay, it isn't important you understand everything I did here. The important part to understand is that I have never done this before. I was able to accomplish it because I understand the principles of object-oriented programming. And so I can look at the patterns involved. If I understand what a constructor is, if I know how to create a new instance, if I know a little bit about inheritance, then that helps in all this. By the way, a button here has its own creation. So if I go to the definition of it, here's a button. And notice here what it inherits from. Notice the I here refers to an interface. We just talked about that, didn't we? Somewhere. Remember we talked about an interface. This inherits from button base, whatever a button base is. I can right click on it and go to definition. Here's a button base. I guess there's other items besides a button that falls under the button base. The idea is you got button base here, and then you got a bunch of children underneath it that are inheriting all those properties. Control, that just must be a generic control. I can right click on that and choose go to definition. A control is a component. So I can right click on that, go to definition. Marshal by reference object. Go to definition. And this doesn't look like it inherits from anything, as far as I can see. Again, it has certain declarations declared here, but that's the idea of object-oriented programming with Visual Studio. Trying to remember what it's called in Visual Studio. It's obviously not called that. They got a name for the framework of what it's called, and I'm drawing a blank. It's called the DOM document object model in HTML, but I'm probably not going to remember it for here, which is sad. Something I should remember. Anyway, understanding what all this this means when you look at it is important, because you just have a general understanding. Okay. Probably more than one constraint. Just talked about that. Excuse me. I was playing with Google Earth this weekend, just trying to figure out what to give workshops on. And Google Earth, I think there was a Earth there, and then underneath the Earth there was countries. Underneath the countries there was cities. I don't think I saw any like states or anything like that. Underneath the cities there was roads, maybe streets. Under streets there was roads, and you can keep breaking it down. The idea is that some of these things inherit information. At the very top level, you probably don't have a lot, because you're trying to define different items here that would inherit down. But it get down to roads here, you might find there's a lot more detail here. What type of roads, direction, so forth. Now, I put those streets and roads as separate because I forget where I was at. I think I was in the Philippines. Because there's a little button on the side, so do you feel lucky or something? There's a little dice with six dots, and you click it, and it takes you anywhere randomly in the world. And one time it took me to China, the mountains up there. Kind of a cool package. I'm sure all of you have seen it before, but that's a concept of inheritance, where maybe you send properties down, values, or maybe methods, or there's just some kind of logical relationship between them. All those countries are on the earth. All those cities are in a particular country. All those streets are in a particular city, and the roads would fall there. Roads, some of them where I looked at were pretty primitive, pretty like gravel type roads. But you never know what part of the city you're in. You find that in any country. Okay, so generic methods. Generic methods help to type safe a method's argument type, which helps in calling a method's parameter for multiple types. You get your return type, method name, and then less than t, greater than t is your argument. Generic method defines by using the less than and greater than. And we saw that over and over, the use of the less than and greater than in Unity. You'd have something that's a component or something that's an audio source or game object or who knows what all you could put in there. And again, we generically got it defined up here. And then our program, we got example, EX, new example. Here's our class called example. I don't see a constructor unless I'm just missing it. Excuse me. And that's called generic method, which has a single generic type. Here's one that has multiple generic types. You got string and integer, where this one just had an integer. And you got constraints on generic methods. Constraints can also be applied on generic methods to restrict types of methods use past values or method calling. You wouldn't do this on a regular basis as a computer programmer. That's more of something you would do if you're designing objects. If you were working for Microsoft and writing the next Visual Studio, you'd have to have very in-depth knowledge on this. If you're writing a new package for Linux, working with objects, again, you have to have a lot of that knowledge of how to set these up. Now we got a collection. Collection helps to manage a group of related objects. In C#, collections are data structures that provide a flexible way to store and retrieve objects dynamically. Unlike arrays, a group of objects in a collection can grow and shrink anytime. Collections are classes that are instantiated to manage a group of related objects. In C#, there are three kinds of collections: system.collections, system.collections.generic, and system.collections.concurrent. Systems.collections is a namespace which contains classes, interfaces that manage a group of data. Stores each data in the form of a system.object type. Therefore, a group of value type data always gets boxed or unboxed. It defines multiple data structures to store and retrieve data, such as list, queue, and hash table. We've got our array list. It can grow and shrink dynamically. Hash table, that's key value pairing. Queue and stack refers to what goes in first in, last in, what comes out. Part of this you've seen at a restaurant, if you've ate at a buffet, maybe. In some places, they have a place to put the plates, and they push the plates down. So they bring out a fresh stack of plates, and they push those down. And each one you push down will be the first one to take off. So that would be the case of last in, first out. The LIFO, however you pronounce it, order. Items in your operating system in a programming language are done on the last in, first out basis. Here's different methods and properties of array list. There's an add an object to the end of the array list, contains, turns true if specific object is in the array list, clone, remove at, clear, count, capacity. Um, Finally managed to break it. Oh, because I dynamically set it up. So since I'm doing it dynamically, it doesn't know what should be there. Interesting. Again, doesn't mean it won't run. Obviously it runs like that, but it breaks the editor here. Let's see if I can remember how to do this. I hard-coded 5 in here, but there's a way to do random numbers. And I don't know if I need to import it in. Random R equals new random. It doesn't like something about that. Show potential fixes. System.random, or up here you say using. Are you missing a directive? Okay, if I click that. Okay, I put the directive in there. If I come up here, well, interesting. I fully expected to see up here using system.random. But that must not be where it's stored at. Maybe just by putting using system up there, it can take everything. Okay. R is equal to, do I need to do a new? New random. Already did a new. Next. Returns a non-negative random integer. So size of A is going to equal to r.next. And then down here, instead of hard coding 5, let's try to put size A in there, see if it still works. And down here, I think I got 5 hard coded again. Size A. This could be really weird if it works, because it could return an integer of 200. So I could have system out of memory exception. Size A, I don't know how much that is. 1.295 billion. Okay, that's obviously not going to work. Have that many buttons. What if this has a range? Let's see. Has a max value. So let's put a max value of 12 in here. 25. Okay, so let's start this now. And that time we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I think. Didn't have very many that time, 3. What's the odds it comes up with 3 twice in a row? 5. Okay. $250. Quite a few buttons were created. Okay, let me do a new. I think demonstrated the power of objects, at least dynamically. The more you work with objects, you realize how much they save coding-wise. Why'd I even come over here? I got a list box. I got a button. List box. If I right-click, go to my properties. Let's see what it's called. It's called list box 1. Double-click the button. List box 1 dot. Dot items dot add. I have an ad. Contains clone, no clone, remove at, both those clear, dot count. Curious about the clone. Some of these I've never seen. Capacity. It might be back here. Clone. No. No capacity either. What you'll see is some of the items that are defined by Visual Studio and you're inheriting, you can use any of these properties on. You'll find these same properties, for example, on a combo box. Here, we're using it for an array. Array list, a list box is just an array of items. So this is a nice way to add an item to your array. Console app. There we go. Array list. Array list equals new array list. Like that. Notice up here, it says using system.collections. I got a collections.generic, but I don't got a systems collection. I wonder if that's system.collections. And now I'm not getting that error anymore. Now again, this is what brings that code in, these definitions. Now, array list. If you've done a new, we just create a new instance of it. Then if I want to add something to it, all I have to do is just do an add. Array list dot add 5. Array list dot add. And notice it's just coming up and asking for an object. So it's not looking for anything particular, just saying it's an object. This is the way that listbox works. When you bring up that listbox, it just very generically, you can add numbers, you can add strings, and so forth. If I do new object test. And obviously not. I'm not going to get syntax right. Now you can do treat just like an array. You can remove 22. So in this case, array list dot remove 5. Now you notice in this example, nowhere do they specify the size of the array. Again, this is giving us a little bit more flexibility when I'm writing code for a list box, and I dynamically get the information from the user to populate that list box. Well, there's no limit on what I can do. I can put 100, 1,000, 10,000. I'm assuming I've tried to do 10,000 elements. But the idea is that you don't know how many objects you're going to have, how many strings, how many integers. This refers to your count, and that's what you do in programming a list box. And we'll get back to programming a list box. Now we're starting to understand some of the basics. Got a hash table. That's where we got a pair of key values. So you got something that keys into another. Like here, I'm associating Bill with Microsoft. I'm associating Paul with Microsoft. I'm associating Steve with Apple and associating Mark with Facebook. So we're adding our keys. Value can be duplicated. You see I got Bill's the owner of 0, and then we're passing in owner, and then we're using Bill as a key into it. This is called by different things in different programming languages. I'm trying to think what it's called in Python, if you program in Python. But there's a way to do that in Python. Kind of a user-friendly way of programming it. Contains key, so you can look up Trump. And then if you don't find it, that's what the exclamation does. Then you can add it and say Trump goes to the Trump organization. Dictionaries, that's what they're called in Python. It's a concept of a dictionary because dictionary, you have your word and you have your definition. So your word is your key into where go look in your dictionary. Then this gives you a setup on the key and value. I've never really used these very much, to be honest. I've used the concept of objects quite a bit. But to retrieve data like this, I think I used a couple of flat files, but 99% of what I did was database work. So that's where you want to store that. You don't want to store it in flat files. You don't want to store it in a dictionary that you lose when they shut the computer off. It's stored off in a SQL file. And for the most part, you don't want to load an entire SQL database into your local memory because it consumes a lot and slows down your computer and so forth. So it's best to leave it in the database and just do your lookups. Some of these concepts, if you're wondering, well, where's it used at, then some of these concepts are built to used in designing system utilities and designing a new programming language. Queue. It's a class of system collections namespace. It stores and retrieves objects in first in, first out order. In other words, it manages a collection of objects on a first come, first served basis. Below us are common methods and properties used in the queue. And you can see those there. I'm not going to go over those. Excuse me. Okay, so objects in the queue. We got queue days equals new queue. Drop on Monday through Sunday. To return the first element of queue without removing it, you do a peek. The statement you do to remove it, dequeue, in queue, adds an element to the end of the queue, and this removes it. Stack, that's the last in, first out principle. These are, you'll see these in like a data structures class. So if you go into computer science and you take the data structures class at WSU or wherever, then you'll see this this concept. The other place I used it in college was in it was a compiler class, and it's been a long time. But when you bring in, I wrote my own compiler like Java or Visual Basic, so forth. Definitely not as robust as that. Very simple, simple programming language. Maybe had 10 to 12 different commands. When you're trying to do order of operations type, your variable name num1 is equal to 3 plus 5 divided by 7, and so forth. You have to take those and you have to put them onto a data structure. I think it was a stack, the last in, first out. Been a while. But that's where it's used at. So you got your push, and there should be somewhere like a pop, I think. This pushes it onto the stack, and pop usually pops it off. Peek looks at it. Here it is. History.pop. That's what happens when somebody goes up and gets a plate. Push the plates down. You're pushing them. You're doing a push on each plate. And then when you want to take a plate, you pop it off. It's the last one that was put in, and that's the first one out. I always wondered about that, if that was a really healthy design. It seems like to me if they never let it go empty, then that plate on the very bottom should have a lot of dust and bacteria and so forth, because it's been sitting there down there in this dark area for perhaps 2 months. But anyway, that's the idea of a push and pop. We got our system.collections.generics. It's a namespace which contains classes and interfaces to manage a strongly typed collection. In a generic collection, data cannot be boxed, unboxed, but data always gets type saved. It's faster and better than classes interface defined in systems.collection. And now I can go over that in more detail. Main thing I wanted you to get out of that last part, just what is a stack, what's a queue, understanding the difference between pushing, popping, what comes off. The first item comes off, or does the last item come off if you take something off of it. And then here's the actual dictionary. That's curious. I thought we had that before. but we have our t key and t value. Um, so that's referring to our key and value pairs. T comes from the fact that it can be any type. See this right here, int and then student. That means we're going to associate an integer with a student, which is a class. It doesn't have to be an integer, because the way that's defined is you can have any type there. Yeah, let's say I'm not going to spend a whole lot of time on that. Q with a type. String days equals new Q string. Slack. Goes a lot of depth, and that'll become important later on, like a data structures class. Not so important here. This concurrent. And I can go over all that. What I want to get down to is working with the strings. There's not going to be any assignment on that first topics. Well, assuming I can get down to the strings. Yeah, I'll just go there fast. Okay. Now here we're going to talk about strings next time, but I wanted to get down to this point. Strings uses store text values. String is immutable, which means once a string variable stores some text in it, it cannot edit again. String is stored as a read-only collection of character objects. Therefore, whenever a string's possible value is updated, it recreates an instance for the string literals, which is not good in terms of memory and process consumption. And we're going to take a look at that in more detail next time. This is where I'll probably, maybe not, since next week's spring break, but I might assign something out of strings. But we'll go ahead and stop the recording there.